Hello scholars, it's EduMath Hub. In this video, I'm going to be explaining Taylor series for MAT 101 students. Okay, so let's take it like this. Taylor series is a power series. That's the first thing you need to know, and it is given by this formula on your screen right now. So it is the sum, as you can see, it is the sum of several terms. These are the terms here. It is the sum. I'm going to teach you a way to remember this stuff. You don't need to memorize it or like cram it or something. I'm going to teach you a very simple way to remember it. So this whole thing that you're seeing here can also be written in another way. So you can also write it like this. Now, this whole thing can be written like as this one that is down here. So Tx here stands for Taylor series. Okay, T of x, or you can say f of x, anyone you like. So both of them are the same thing. So this is a sigma notation sign, meaning sum. So you can see that these two are the same because you have plus here, plus here, plus here. It is the sum of several terms. Now, these terms are easy to identify. The first thing you have in this series here, this sum, is f of a. In Taylor series, you'll be evaluating the series at a particular value of x. If you're given the question, you always see the evaluate so series at x is equals to a. You'll be given the value. Okay, this value will be a constant, a number. So whenever you see a, you just replace that number there. So you're going to find f of that value first. You're going to put that number. Let's assume it is 5. You're going to put it into the function that you are given. Then f prime of a means the first differential. That means you need to differentiate that function once. So f prime of a stands for the first differential. So you differentiate once. That's f prime of a. Then you put in the value that you are given in the question. Maybe you're told to evaluate at 5. So that will be f prime of 5. Then you get a particular answer there. Then this next part says just means x minus a. This x is always constant, always in all the formula for Taylor series. Every question you are given, there will always be x there. So just do x minus 5. I'm assuming a is 5 in this question. Then 1 factorial, that will be the first one. Second one will be 2 factorial, but you're going to be having f prime of a, which means the second differential. That means differentiate the function the second time. Then you're going to have x minus a squared. You see that the number that is here, 2, is what is also here. Is 3 that is here. You also have 3 here. The next one will be f prime of a, that's 4. Then x minus a raised to the power 4 over 4 factorial. So it's just repeating like that. So 3 factorial will be here, raised to the power 3 will be here. X minus a, 2 will be here, 2 factorial. The imaginary one is here, 1 factorial. Then this one is just f of a. So it's easy to remember. You can also use this one to remember it. This one is f of n over n factorial a x minus a is by now when the value of a becomes 0, if the function is being evaluated at a point centered at a is equals to 0, this whole Taylor series will become what is called Maclaurin series. So Taylor series evaluated at x is equals to 0 will give you what is called Maclaurin series. So in this formula here, just put a is equals to 0. That's the meaning, a is equals to 0. So Maclaurin series will be mx. That will be mx. That will give you, come here and put a as 0. That will be f of 0. Okay, plus this will be f prime of 0. X minus 0 will give you x divided by 1 factorial plus f prime of 0. X minus 0 will give you x squared over 2 factorial plus f prime of 0 x cube over 3 factorial plus and so on like that. So you can see the difference. This one is Maclaurin series because it's evaluated at s is equals to 0. As in this case, a is equals to 0. But in Taylor series, a will be a number that is not 0. Maybe any other number. So let's take the question. So we have a sample question here. Determine the Taylor series at s is equals to 0 for f of x is equals to e raised to the power x. The first thing we're going to do is, don't forget that we are evaluating at s is equals to 0. That means at this point, a is equals to 0. And when a is equals to 0, that means we have what is called Maclaurin series. So all we're going to do right now is just write the Maclaurin series. Don't write Taylor series, though. Just write Maclaurin series. So just write m of x is equals to f of x equals to, so you're going to have f of 0 first. Okay, plus, you're going to have f prime of 0 x divided by 1 factorial plus, then I'm going to 2 now, so I'm going to prime it twice. F prime of 0, I'm still going to have x, but I'm going to put 2 here, as in 2 here over 2 factorial plus, I'm going to prime it 3 times now, f prime 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 of 0. Okay, now I'm going to put x to the power 3 here over 3 factorial. Let me just do it 4 times plus the last one here. This will be f prime 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 prime, that's 4. 0 will be here, x4 over 4 factorial. So at this point, yeah, okay, don't bother yourself doing up to 5 times. 4 is okay. Now we have 5 times here, 1 2 3 4 5. This one is okay. Now let's get the differential. So the first thing I'm going to do, you see that you have f of 0 here, f of 0. So you're going to do f of 0 first. F of 0 will be, look at the function that they give to you, that's e to the power x. So f of x is e to the power x, Abi. So f of 0 now will be, just put 0 here, that will be e to the power 0. Now on your calculator, exponential of 0 will give you 1. Okay, that will give you 1. So exponential of 0 is 1. So the next part is f prime of x. Now we're going to find f prime of x. Before you can do f prime of 0, you must know f prime of x. So let's differentiate this guy. So you have f prime of x. This is f of x here, don't forget, f of x. So if you differentiate e to the power x, if you differentiate this one here, e to the power x, anytime you differentiate e to the power x, you must always get that same thing. If you differentiate e to the power x, you must always get e to the power x. So this one will give you e to the power x here. Okay, then you now do f prime of 0 now. That will still be, anywhere you see x, just put 0 there, exponential of 0, that will give you 1. Then I'm going to this next part, f prime prime. F prime prime of x now. That means I'm differentiating this one. I'm differentiating f prime of x. But this f prime of x is the same thing as this one. That means I'm just going to be getting the same thing. So this one will be e to the power x. Then I'm going to do f prime prime of 0 now, because that's what I have here. So I'm going to get that same e to the power 0, which is still 1. If I do the third one, f prime 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 of x, I'm still going to get e to the power x. Okay, then if I put 0 there, I'm going to get exponential of 0, that will give you 1. So since this function is the same, because e to the power x, if you differentiate it, you're going to get that same e to the power x. So let me just do the fourth one, then we'll put all the values together. So f prime 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 of x will still give me e to the power x. Then I'm going to put 0 there, that will still be 1. Then all these answers now, I'm going to put them together and slot it into this formula here. Slot it here. Anything I get to be the Maclaurin series. So I'm just going to have mx, which is the Maclaurin series. So I have f of 0 first. F of 0. So f of 0, you can see it you can see it from here. F of 0 is 1. So f of 0 is 1. So I'm going to write 1 here plus f prime of 0. You can see it from here. F prime of 0 is also 1. So I'm going to write 1 here. Then I'm going to put x at the side, divided by 1 factorial at the bottom part, plus f prime prime of 0. Look at it here. It's also 1. F prime of 0 is also 1. So I'm going to write 1 here. I'll put x at the back and put 2 factorial under. Plus f prime 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 of 0 is also 1. As you can see here, it's also 1. So it will be 1 x3 over 3 factorial plus this one too is 1. Let me just make it fast. Plus and so on like that. So you notice that 1x is still 1. So that will be 1 plus this is x over 1 factorial is 1 plus x squared. You can put 2 factorial like that. Don't evaluate it if you like. X3 over 3 factorial plus x4 over 4 factorial plus and so on like that. Now, if you don't see this answer in the option, you can also write it like this. 1 plus x over 1 is x, right? Then this will be x squared over 2 factorial means 2 plus x is power 3 over 3 factorial means 3 times 2 times 1. That will be 6 plus x is power 4. 4 factorial means 4 times 3 times 2 times 1. So that's 24 plus and so on like that. So this is e to the power x. This is the Maclaurin series for e to the power x. So that's how you get your answer. So any of these two answers are correct. You don't leave it like this or you leave it like this. So we're going to take the second question, which will help you to understand it better. This question says that expand the function f of x is equals to ln x at s is equals to 1 by Taylor series method. Now, Taylor series method, I've already written it here for you. As you can see, this t of x. So this is Taylor series here. So very easy to understand. So you have f of a, f prime of a, x minus a is to the power 1. You have 1 here. Then when you have 2 factorial here, you're going to have 2 here. When you have 3 factorial here, you're going to have 3 here. When you have 4 factorial here, you're going to have 4 here. This will be f prime 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 prime. That's 4 times. This will be 3 times, 2 times, 1 times, 0. So at this point, s is equals to 1, as you can see. Now, take note of the fact that this ln x is the same thing as log to base e of x. So they might write the question like this or like this. So it's the same thing. Now, let's start solving it. Now, the first thing you're going to do is like this. The first thing to find is write your original function they give to you. The function is f of x. Okay, that's the function. Then they give you ln x. You're going to differentiate it 1, 2, 3, 4. Okay, 4 times. You're going to differentiate it 4 times. 1, 2, 3, 4. So let's start with the first one. So for the first one, you have f prime of x. So if you differentiate this one, you're going to have 1 over x. So when you differentiate ln x or log to base e of x, the answer is 1 over x. So the next one, you have to differentiate the second time. That will be f prime prime of x. So if you differentiate this one, you can write this thing like this. Instead of writing 1 over x, just write minus. Just write x to the power minus 1. Write it like this. So if you differentiate this one now, you're going to get minus 1 x to the power minus 2. Or minus x to the power minus 2. This is what you're going to get. So this one is f prime prime of x. Then differentiate the third time, f prime 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 of x. And differentiating this one now. So this minus 2 will just times this minus 1 here that is here. So that will give me 2x. I'm going to subtract 1 from this one. That will be minus 3. Okay, now I'm going to differentiate the fourth time. So for this 3 here, we times this 2, that will be minus 6x. This one will be, become minus 4. I'm subtracting 1 from it, from differentiation method. Now I've gotten all my differentials. Now the next thing to do, I'll have to start putting f of a, f prime of a, f prime prime of a, and so on. But taking note of the fact that s is 1 in this question, x is 1, so you're putting value as 1, you're putting x as 1. So for this first one, f prime of a, I'll write f prime of 1. Okay, I'll put 1 here, 1 over 1, the answer will be 1. And don't forget that 1 raised to power anything, even if it's a negative number, 1 raised to power, even if it's a decimal number, 1 raised to power anything is 1. So I'll come to this next one. This is the second differential here. So I'm going to do f prime prime of 1. So I'm going to put 1 here. That will be minus 1 raised to power minus 2. Everything here like this is 1 raised to power something. 1 raised to power anything is 1. So the answer is with minus 1. That will be the final answer. Okay. Then for the third one, I'm going to put 1 inside here. That will be 2 raised to power 1. 2 times 1 raised to power minus 3. The answer will still be 2. 1 raised to power anything is 1. 1 times 2 is 2. The next one is minus 6. Minus 6 times, this will be 1. 1 raised to power negative 4. 1 raised to power anything is 1. So 1 times minus 6 will give minus 6. So these are my answers. This one here is f prime 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 of 1. I already have this one as f prime prime of 1. And all these other ones here. So I'm going to put them together now into this part and get the final answer. So look at how the answer will be now. I'm going to start with the first one, f of a. F of a is the first one. This is f of 1. Now f of 1, I'm going to put 1 here. I've not even done that one. Sorry about that. F of 1 is the first one. I'm going to put f of 1 here. So f of 1 means ln of 1. So f of 1 means ln of 1. Ln of 1 is 0. Okay, so I'm going to start with 0 now. So let's start like this. The answer will now look like this. I'm starting with f of a, which is f of 1. So f of 1 gave me 0. So that will be 0 plus. Okay, I'm now here now. I'm at this point. So I need f prime of 1. F prime of 1. Look at it here. The answer was 1. F prime of 1 is 1. Is here. So this one give me 1. Then I'm going to write x minus 1 because a is 1. X minus 1. Okay. Over 1 factorial plus, I'm at this point now. So I need f prime prime of 1. Where is it? Look at it here. F prime prime of 1. What was the answer? Minus 1. So I'm going to write minus 1. Then I'm at this point now. So I'll say x minus, a is 1. I'm going to square this part over 2 factorial plus, I'm at this point now. So I need f prime 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 of a. That's the third one. That's this one here. That's this one. F prime prime. The answer that we got was 2. So I'm just going to put 2 here. Okay. Then I'm at this point now. I'm going to write x minus 1 3 divided by 3 factorial plus the last part, which is f prime 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 of a. That's the fourth one. The answer was minus 6. You can see it here. So I'm going to write minus 6, as you can see here, minus 6. Then I'm going to, sorry about this small space, I'm going to write x minus 1, then raised to the power 4 over 4 factorial. Now, so just to make it look neat, I'll rewrite it on another paper. So the answer is 0 plus anything is that same thing. So you can ignore this first one. So that will be 1 plus, this will be x minus 1. Plus times minus is minus. So that will be minus x minus 1 squared for 2 factorial. Then plus 2 x minus 1, 3 over 3 factorial. Then plus times minus minus 6 x minus 1, 4 over 4 factorial. So this is the answer. This is the Taylor series expansion of lim x at s is equals to 1. Now for this next one, we have to find the Taylor series for cos x at s is equals to 0. So s is equals to 0. This is Maclaurin series, okay? Now just do it like this. So you have Maclaurin series. So you're going to have f of 0. Everything should be f of 0, f of 0, f of 0. So f of 0 we start it. Plus you're going to have f prime of 0. Then you're going to have x divided by then 1 factorial. Plus you're going to have prime prime now. F prime prime of 0. X 2 will be here. 2 factorial. You're going to have 3 primes now. Then the last one. Let me just make it 4. You can also do it to 5, but it's 4. That is 4 is okay. Now plus and so on like that. Now once I've gotten this part, the next thing to do is just to check for what you are given. The value is at s is equals to 0. So we need to differentiate this thing 4 times. No, I did it from 1, 2, 3, 4. I need to differentiate 4 times. I'm going to write differentials at this point. So I'll start with the first one, f of x. So I need f of 0. F of 0 will be cos 0 because that's f of x. So f of x is cos x. So that means f of 0 will be cosine of 0. Now, cos 0 on your calculator will give you 1. So cos 0 is 1. Okay? Now leave that one like that. Differentiate now f prime of 0. So I'm going to differentiate once f prime of x. If I differentiate cos x now, if I differentiate cos x, this is cos. If I differentiate cos x, I'm going to get minus sine x. So let me differentiate second time. F prime prime of x. So I'm differentiating minus sine x now. If you differentiate sine, you're going to get cos. So this will be minus will still be there. Minus cos x. So let me differentiate the third time. F prime 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 of x. If I differentiate cos, I'm going to get minus sine x. But because there's a minus here, everything will be plus. So this one will just give me sine x. Then the fourth one. If I differentiate sine x, I'm going to get cos x. So now I need to now start getting the values. So f prime of 0, that will be here. F prime of 0. So I'm going to put 0 here. That will be minus sine x is here. I'm going to write 0. F prime of 0. So sine 0 is 0. They will come here f prime prime of 0. So I'm giving minus cos 0. That will be minus 1 because cos 0 is 1. So that will be minus 1. Okay, this one will be f prime prime of 0. This one will be sine 0. I'm using 0 because in the question it says s is equals to 0. So sine 0 is 0. Okay, the last one is f prime 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 4 times of cos. This one will be 0 now. So cos 0 is 1. So you notice something that at the first time you have 1, then you have 0, minus 1, 0, 1. So it's alternating. So at the point where you have f prime of 0, it is 0. When you have f prime 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 of 0, it is also 0. So just take note of that fact. So you can easily simplify this thing. You easily simplify this part. You'll not be writing too much stories. So let's do it like this now. Let's get the final answer. F of 0 now from our formula. F of 0 is here. You can see it. F of 0 is 1. So I'm going to write 1 here. F of 0 is 1. That's the first part. Plus f prime of 0. F prime of 0 is 0. So 0 times anything is 0. I can skip that part. Plus f prime prime of 0. F prime prime of 0 is minus 1. So I'm going to write minus 1. Then x squared divided by 2 factorial. Plus f prime prime of 0. Look at it here. F prime 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 of 0 is here. It is 0. So that means I'm putting 0 here. 0 times anything is 0. So I can skip this one. I can skip this term. Let's write 0 here. Plus f prime prime prime. That's 4 times. That's the one that is here. 4 times. I'll give you 1. So just come here and put 1 here. That will be 1. Then x is to the power 4 divided by 4 factorial plus, so it's going like that. So the final answer will look like this. Maclaurin series is 1 plus, now skip this 0, come to this next one. That will be minus 1 x squared over 2 plus x4 over 4 factorial plus, and so on like that. And you can also rewrite it like this: 1 minus x squared over 2 factorial plus x4 over 4 factorial plus, you can see the pattern. The next one will be 6 factorial. Okay, that will be x6 over 6 factorial. In case you want to go further, you can write it like this: 1 minus x squared over 2 factorial plus x4 over 4 factorial minus x6 over 6 factorial plus x8 over 8 factorial. You see the pattern. It's alternating in signs, like minus and plus, and it's only even numbers that are there. There are no odd powers. Everything is like 2, 4, 6, 8, 10, and so on. And the signs are alternating. So this is the Maclaurin series. So for this next one, you have to expand the function below by Taylor series at x equals to 1. So they are already giving you the function. The first thing to do is to just write out the Taylor series. So now from this point, the next thing is to start getting your differentials. But before you start, first of all, get your f of a. Your f of a, in this case, a is 1. So find f of x first. F of x is in the question, x4 plus x minus 2. So f of 1 will just be, put 1 into this formula. So that will be 1 plus 1 minus 2. 1 is to the power 4. We think that's 1. So 1 plus 1 is 2. 2 minus 2 is 0. So everything here will be 0. F of 1 will be 0. That means our answer will start with 0 plus. Then next thing, start getting your differentials. Start differentiating. So the first one will be f prime of x. So I'm going to differentiate this guy now. X is to the power 4 plus x minus 2. So this will be 4x is to the power 3 plus 1 when you differentiate. So I'm going to put, let me not put the values yet. Let me just go do the second differential. So I'm going to put f prime prime of x. So I'm differentiating this one now. So this will be 12x squared. Okay. Then let me differentiate to the third time. F prime prime. This one will be 24x. Then the fourth time, that will just be 24. Then I need to start finding the values at each point s equals to 1, as you can see. At each point s equals to 1. So I've already done the first one, f prime of 1 now. This will be, I'll put 1 here. So that will be 4 times 1, 4. 4 plus 1, that will be 5. F prime prime of 1 now. So I'll just put 1 here. 1 is 1 raised to the power 2 is still 1. 12 times 1 is 12. So I have my values. F of 1, put 1 here. 1 plus 1 minus 2, that will give you 0. F prime of x, I'm going to put 1 here. 4 times 1, 4. 4 plus 1, 5. F prime prime of x is 12x squared. F prime prime of 1 will be, putting 1 here. 12 times 1 is 12. Next one, f prime 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 of x, that's the third differential, is 24x. So f prime 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 of 1 will be 24 times 1. I'm putting 1 here, that will be 24. The last one, which is the fourth differential, there's no x there. So f prime 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 of 1 will just be 24 because there's no x. Now just come and put everything inside here. Substitute everything inside here and get your answer. So I'm starting with the first one, f prime of 1. F prime of 1 is 0. So I'm starting with the first one, f of 1 is 0. So I'm going to write 0 plus, this plus is this plus. F prime of a, that's it here. That's f, a is 1. So f prime of 1. F prime of 1 is 5. So I'm going to write 5 into x minus, don't forget a is 1. So I'm going to write x minus 1 here. Okay, so dividing by 1 factorial plus, let's look for f prime prime of 1. F prime prime of 1, that's 12. So that will be 12x minus 1 squared over 2 factorial plus. Now let's look for f prime 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 of 1. That's the third one. Got it here. That's 24. So I'm going to have 24 x minus 1, 3 plus the last one is 24 too. So this will be 24 x minus 1 raised to the power 4, 4 factorial. So the final answer can be like this. Now if you want to go further, you can start dividing. This will be the same way. 2 factorial is 2. So 2 in 12, that's 6. So you can write 6. 3 factorial is 6. 6 divided by 24 divided by 6 will give you 4. 4 factorial is 24. 24 over 24 is 1. So you either leave it like this or you leave it like this. Any of the two answers are correct. So basically, this is how you do Taylor series. So now we take the next one. You have to expand the following function by Taylor series method at s is equals to pi. Now this is radians. So when you say pi means 180 degrees. Okay, just keep that in your mind. Pi is 180 degrees. 2 pi means 360 degrees. So we have to evaluate this one at 2 at so we have to evaluate cos 2x at x is equals to pi. So we are doing Taylor series. So first of all, write a formula first. So before you proceed, you have to find this first part first, which is f of a. So you already have f of x, which is in the question, which is cos 2x. So you're going to look for f of pi plus x is equals to pi, or a is equals to pi, anyone you like. So f of pi will be, come and put pi here. So that will be cos of 2 pi. 2 pi will be 360 because pi is 180. So 2 times 180 will give 360. So cos 360 is 1. So that means this first one is 1. That means our answer will start with 1 plus. Then the next one is, let's start differentiating now. So start differentiating. You have f prime of x. The first one. So I'm differentiating cos 2x. So I'm going to get, differentiate this. Don't forget, if you differentiate cos, you will get sine. So if you differentiate cos, you will get minus sine 2x. So I'm going to multiply by 2 again. So that will give you minus 2 sine 2x when you differentiate cos 2x. Okay, then let me go second time. So I'm going second time now. That will be f prime prime of x. I'm differentiating this one now. If you differentiate sine, you're going to get cos. So this 2, just times this 2. That will give you minus 4 cos 2x. And then go the third time. For the third time, we're going to have f prime prime of x. Differentiate cos, you're going to get sine, right? But it will be negative sign. So at the end of this, thing will be plus because you're going to get minus sine. So that minus will cancel this one. So this 2 just times this 4. That will give you 8 sine 2x. Then for the last time, that will be f prime 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 of x. The fourth time, this will just give you 16 cos 2x. Just be changing it like that. So now we have everything we need. The next thing is to just start putting the values. F prime of a. A is pi. So if I put it as pi, the first one will be f prime of pi. F prime of a or f prime of pi. F prime of pi. What are you going to get? So this give me sine 2 pi. So whenever I see s, I'm putting pi there. So this will be sine 2 pi. 2 pi means 360. Sine 360 is 0. So 0 times all these ones will give me 0. So this one will be 0. In short, anyone that you have sine, it will be 0 because sine 360 is 0. This one too will be 0. That means f prime 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 of 0 is going to be 0. But anyone that you have cos is going to be 1. So this next one will be f prime prime of x. There you have cos here, Abi. So since you have cos 2 pi, that's 1. 1 times minus 4, that give you minus 4. Then if you do for the last one, f prime 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 of pi, change on to pi. So f prime 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 of pi will give me cos pi, cos 2 pi, that's 1. 1 times 16 will give me 16. So I have all my answers now. I'm just going to put them inside here. So the first one I'm starting with is f of a. Now what is f of a? F of a is f of pi. F of pi is the first one. That gave me 1 as the answer. That will be 1 plus. I'm at this point now. So I need f prime of a or f prime of pi. Look at it here, 0. 0 times anything is 0. So I'm going to skip that part. Because this one is 0. 0 times anything is 0. Plus. The next one is f prime prime of a. That's f prime prime of pi. Is here. So this one will give me minus 4. Because everything here will give me 1. 1 times minus 4. So minus 4. I'm going to write x minus pi. X minus pi. X minus pi. I'm going to square that. Then 2 factorial. Plus. Next one is the third one. F prime prime of a. F prime prime of pi. That one is 0. So I can skip this one. Because everything here is 0. So I'll just skip this one. Everything here is 0. Plus the last one. That one gave me 16. So I'll just put it there. Plus 16. X minus pi. 4 over 4 factorial. Then just put everything together. So that will be 1 plus, so I'll give you minus 4 x minus pi over 2, 16 x minus pi, 4 factorial is 24. So plus and minus is minus, Abi. So it continues like that. But these are the first 3 terms, so you can just stop here. So this is the Taylor series expansion. If you like, you can cut. If you want to cut, you can just cut. But this is the final answer. If you have gained something from watching this video, give it a thumbs up and share this video with your friends. If you are new to this channel, make sure you subscribe for more videos like this. Thank you for watching. Also check out the next video on your screen, which will help you to understand set theory.